Well, hi, good morning. Thanks so much for joining me here. It's November 12th today, and I'm going to continue with changing out paper capacitors. There's only 4 of them left in there by my count, and they're all involved in the intermediate frequency stage. So I think that's kind of interesting. So I've set up a test here which I hope will reveal any changes or improvements that might occur. What I've got going is, first of all, my big old signal generator here is going to be putting out a signal at 455 through the IF of the radio. We're going to hear that come out of the speaker. What comes out of the speaker is going to show up as one of these 2 lines. The signal coming out of the IF at the detector, just after the detector, is going to be picked up by my other line on the oscilloscope, and also on this voltmeter, so we can read the AVC voltage on the radio. So rather than have a single frequency come out of here, because I'm limited to just 400 and 1000 from the machine itself, I've got the output of this signal generator, the audio output signal we were using yesterday, and I'm feeding it into the modulation input on this signal generator over here, this guy here. That's this cable. Bringing it in, so it should be able to reproduce the 80 Hertz or whatever it was that we were looking at on the oscilloscope, and seeing that it was still a little bit distorted when the volume was cranked up. So in other words, I'm trying to send in the same audio signal, only instead of feeding it straight into the audio circuits, I'm trying to feed it in as a modulated IF signal. The 4 capacitors, here they are in my little sketch, 1, 2, 3, and 4. This guy here is a great big honker. You can see him back here. And in earlier on, in inspecting the radio, I had noticed some plus signs right down at this end, indicating this is the positive end. So positive end, so this has to be an electrolytic capacitor here. It's a big one. It's a 10 microfarad electrolytic capacitor. And what it's doing is it's quieting the screen circuits in this radio. So it's an awfully big capacitor to use for this purpose. They're not normally quite that large. Because it's electrolytic, it doesn't work so well at higher frequencies. So it has a brother, that's this one right here. This is a 0.1. So that's a 10. This is a 0.1. This is a regular paper one. And his job is to do the same thing as this guy, only at higher frequencies. Maybe at RF frequencies. To really try to quiet the screens in the screen connections to the tubes in the radio. These other 2 down here, I actually looked at yesterday, but I can't remember offhand what they are. So we'll start looking at these 2 on the schematic. We'll look at all of them on the schematic and see where they are. Now, the way I'm picking up the AVC is through this white clip lead onto the top of the volume control, or the input side of the volume control. And we'll see on the schematic too that that's a good spot for doing that. That's where we're at. Okay, let's look at those 4 capacitors on the schematic. See what we can make of that. Let's start with the wiring diagram. So the 4 capacitors I'm going to work on, the big guy is this guy up here, C23. You can see it's grounded to the chassis at one end. Other end, screen grid, SG. Come around here, screen grid on another tube. And here we see C18, this is the 0.1 connected. This terminal connected to the chassis here. So these 2 capacitors, even though they're separated here on the diagram, they're actually in parallel, basically. The other 2 is C22 here and C24 here. Okay, let's look on the schematic, see if we can find them. So here is 18 and 23. So here's the 10 microfarad electrolytic and the 0.1 brother of it, and they're both, you can see, connected to the same line here, which is the screen grid. I had to repeat that for some reason. Now C22 and 24. So here's 24. That's a fairly large 0.1. So here's a cathode resistor on the cathode of the IF tube. And this is the bypass for it. That's what C24 is doing. So it's basically providing a signal ground here. And 22. Here's C22 here. 0.05. It's providing a signal ground right at the bottom, if you like, this secondary side of this transformer. So when I'm doing this test right now, I'm going to be feeding a frequency, probably 455 or somewhere very close, whatever goes best through the IF. I haven't tried retuning the IF or anything like that. So just put the main frequency through. We'll get a reading on the AVC meter and whatnot. Then I'm going to be changing these capacitors. Don't think the screen would have any, these two would have any effect on the tuning of this, but it seems to me this might. And this one, I don't think it would affect the tuning of anything, but this one in particular. So why don't we start? We'll do these two. We'll run the test before I do anything. Then we'll do these two, and we'll see what happens, because that's just affecting the screen. And then we'll fool with these last two after that. That's the plan. Okay, let's see how this goes. So first, I'm going to power this guy up, down. Okay. So we should expect this thing to make a sound of 1,000 hertz. This is set to 1,000 hertz right now. And we'll see. Okay, we're going to put it on full power here. Okay. Oh. Okay, so we're on band A. Well, that shouldn't matter. That should not matter. Something not right here. Let's just vary this frequency here. No. Okay, I've got something here that's not correct. Let's take the scope off of here. Not making any difference whatsoever. Okay, so far not so good. Just looking everything over. Well, I wonder if I've got this connection here wrong. Okay, first attempt. Not so good. Got to steady up here and see what I've done. Okay, what I discovered was I had left the push buttons set on the phono input setting, so I switched it to one of the radio settings. Bingo. Let's just check the IF frequency here a little bit. Okay, what I'm going to do is I'm going to watch the AC meter over here. It's 150 volts scale. It's a pretty strong ABC voltage. 50 volts. Almost 40 volts. Oh, look at that. Whoops. That's how the astronaut ruined the camera on the moon. Aim the camera at the sun. Don't do that. Okay. So we essentially have it set up here the way I want it. So I'm going to switch now to the audio input. No, let's take a look at the oscilloscope first. What do we got happening up there? Okay, so the lower one here is looking at the sound in the speaker. Well, that looks terribly noisy, eh? The upper one is looking at what's coming out of the IF. DC there. Okay, my oscilloscope's not going to trigger, so I'm having a little bit of trouble looking at this. Okay, we'll leave it like that. So it looks like there's some kind of hum. That could be because of the way I've got equipment connected. I don't hear the hum. And it looks like there's a couple things going on. But then you see the main 1000 hertz signal there, I'm pretty sure. Let's drop it to 400. Yeah. Is that coming because I've got things grounded funny here? Don't really see how the this signal is coming from the voice coil of the speaker, and the voice coil is isolated away from everything. I'm not sure where that comes from, where this hum is coming from, or whatever it is that's doing it, unless that's just part of the radio. Maybe that's part of what we're trying to fix. Okay, so I'm going to switch now to the other audio. Now I think I'm sending an 80 hertz signal over. But you know what? I'm not, because the strength is minimal. There's no strength. So what is that? Now that's just coming from nothing. Is the volume turning up? Well, you can certainly hear the hum there. Well, I've done nothing to the power supply. Some of that could be power supply hum. I don't know. Not sure. Okay, a little difficult to continue with this. I'll pump in this frequency here. So now that's what that's what 80 looks like. Well, obviously it's 80 mixed with that other thing, or things. Okay, let me go up in frequency here. Okay, that's 80. What if I go down? Starts wiggling there. That's 30 hertz, and it's doing something at the speaker. So the amplifier range is pretty darn good. That's 80, 90 rather. It's 100. Now you can hear that. Whoa, 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 whoa. That's almost 120. Isn't that interesting? Almost double 60. I think that really tells us it's a 60 cycle hum in the output. I don't think that's going to be affected by anything I'm doing in terms of changing capacitors. What is more likely to change is this level here. So why don't we concentrate on that. Just incidentally, if we go back to the scope, the other one is this level is the same thing as what's on the AVC. This is the output, just scoped. So why don't we do this? Why don't we make this a little less important? Make this a little more important. Keep it like that. It's about 1.5. I better write some of this down. There's more than one thing for me to remember. Probably won't. Okay, so 1.5 divisions. And 825 volts exactly of AVC. Minus 25 volts, in fact. Let's just do a little sensitivity check here. Tuning the radio have any effect? It's a little interesting. How come it went down there at one point? That's the end of the run. Well, that's interesting. Let's go back up where it goes down. Wonder. Look, that's another observation. All those heterodyne sounds and stuff like that. That's a very important observation. Okay, we're at the other end. Just go to a quiet spot here. Now, if I fiddle with the volume, does that change any of these? Only the audio one on the oscilloscope. Which, if I just do this, you can see everything. Okay, volume. It's not affecting this reading. Tone. Wow. Yeah, I remember when the tone was set to the highest treble setting, it eats up the bass. And you can see it. Right there, you can hear it. Boy, that takes all the hum out. Is that because we can't hear the... Let me just... Oh, I can drop this. I don't hear any 60 cycle hum, but maybe it's just too low. Okay, I want to set that to 30. 30%, I'm afraid I can't. Meter reads... Modulation. Well, I can't, I don't think. Now that's the signal generator's own 1000 hertz. Okay. Why the hum got louder there, I don't know. Who knows? All kinds of stuff I don't know. Who knows? Okay, so I think we're good. This seems quite stable. I've written down the value. It's gone up ever so a little bit. Let's just vary the RF input strength here. Yeah, you can see I can. So I'm going to set this at exactly 25 straight up. Now we don't want to make any changes to anything except change the two screen capacitors and see what happens. Better just turn this off right now before I stick my fingers in the back of that radio. Okay, I'm going to do those capacitors now. Okay, we got two capacitors here to check. Let's do that. See what we get. Do the smaller one first. It's a regular non-polar capacitor. Fairly big one, 0.1. Okay, watching the eye here. Here we go. Well, it opened about halfway. 50 volts, 150 volts. It's not going to open. Really testing, very typical of an older capacitor. Okay, now this guy though. So he's electrolytic, so we need to flip this like that. We need to make sure we put the positive on the positive. Turn that back to 50. Okay. 50 volts, what do you say? So on this tester, 150 shows it to be fine. 250. Okay, I'm going to give it a moment there to discharge, then we'll try reading the actual capacitance here with this. And that would be supposed to be 10, so it would be 0.1 to 50. 0.1 to 50, here's 50, there's 10 right there. So we expect the eye to pop open as I swing this past the 10 point. So the eye is not responding at all. Is that because there's still charge in the 20 to 1,000. Maybe we'll pop open here. So we get no. So it's very hard to, you can't really see it in the camera, but nothing happened at all. The eye remained closed the whole time. Let's test it with this one. I'm holding this in my hand. If it's got any significant voltage, we'd know by now. I just want to check it to make sure it's got nothing residual in it. Over 2 volts. Could be why that test didn't work. Interesting, it's going up, up, up. So we need to put a short on this for quite a bit longer in order to test it properly. Sounds like a good time to go and drink some coffee. So I'll put the short on it here. Just leave it there. Coffee time. Okay, let's see what's happening with this shorted capacitor. Was the short in place? 0. How surprising. With the short off. Here we go. See it going up? So there's two possible reasons for this. One is that there still is charge in the dielectric, and it still hasn't come out yet. And so that charge in the dielectric is what's causing this. Another possibility is this thing is turning into a battery. There's no doubt mixed metals in it. The leads, whatever they used inside, the foil they used inside. Well, I just don't think you can take a capacitance reading on a capacitor that's developing 1.6 volts on its own. Now if we try to read some current out of there, this meter's not going to be the most sensitive. 2 milliamps, that's pretty sensitive. Okay, 2 milliamps, let's give it a try. Can we draw any current from this thing? Maybe I'll put the red lead on the positive end. Tiny bit. You can see it discharge the capacitor because the meter is basically a short circuit, and it hasn't got enough juice to even show up on the meter. I can remove it. Count to 13.5, put it back on. There it goes again. I think a lot of these old capacitors turn into batteries. Very lousy batteries late in their life. In most cases it's not going to do anything in the radio. It's going to throw off the tests I'm doing, trying to read its capacitance. Let's give it a go anyway. We'll see what it says. Don't think we can hurt my little tester here. And this is applying complicated signals to these things it's testing. So it comes out at 3,000 nanofarads. So that would be a 0.003. That's not very good for a 10. 0.003. But for all we know, the reading is completely bogus because of the battery effect. Let's just try it the other way around. See if we get a completely different reading. It's not completely different. 0.004. 31% V loss. Can you see that in there? Is there any doubt that it's bad? I don't know how else I could really test this. Take a resistor, a known voltage, calculate the time constant, try to charge it, see how long it takes, draw the curve. You can do stuff like that. But I'm not going to. Okay, so I have the two new capacitors in there. In the meantime, I realized where I have this scope lead, which is showing the RF up here, is actually just monitoring the output of my signal generator. So, but that's handy too. That was at 1.5 divisions, and it still is 1.5 divisions. Shouldn't have changed. Okay, so everything is the same as it was. And just turn the set on, see what happens. I have to plug it in. There we go. Just give it a moment. 10 bulbs are fine. Here comes the ABC. You can hear the motor boating sort of sound. So we're still putting in 115 hertz. There we are. So the real question here is, there's a couple questions. First, let's just take a look at the reading on the AVC meter. Is now 7. Not 7. 22. 22. There we go. 22. So it's slightly less. Now, why is that? It could be all kinds of reasons. It could be because the tuning of the IF has changed just a touch. So I'm going to adjust my signal generator. It's at 452. Watch that meter. Down. Down. So didn't change the resonance of the circuit at all. Reduce the AVC value. Why is that? It's not very much of a change. Less AVC voltage means less output from the IF. So somehow doing these actions caused less output from the IF. Is that a bad thing? I don't think so necessarily. Let's see what we can see of the audio circuit here. I mean, you might think that's a bad thing. You want it to get stronger. That's what I would normally think, but not necessarily. Oh my gosh, who's calling for me? I'm being called. Okay, we'll put this guy up a bit. This guy in the middle. That's actually a pretty nice looking signal. It's wobbly though. Let's just try. What if we speed this up a bit? Slow it down rather. It's very hard to look at. So that's 115. I'll take it down to 80. Hang on there, Peanut. I hear ya. He's in here now. He's broken in. He's in. So again, there's all the kind of weird shaping in here when I've got this running at 80. So I'm feeding it 80. I think it's mixing with a 60 and giving this really weird pattern. So probably if we check the power supply, we'll find that there's a hum in the power supply. Oh my gosh, Peanut, really? As is often the case, I have to go and play with my cat a bit. Holy smokes, you're crying a lot. I see you. I hear you. Okay, I'll stop for now. We'll look for a power supply hum. Okay, let's take a look at the power supply hum factor. We'll look at it on the oscilloscope. I'm just going to go on the big filter capacitor, the original one. That's all that's in here. It's 3 capacitors. Okay, so 2 of them are on either side of the field coil. So one is the input side. You'd expect a fair bit of hum there. And then on the other side, you should have virtually no hum sitting there. And the third one is it's the bypass for the output tube, cathode resistor. So we'll just look at all 3. I don't know which is which offhand. We'll just see what's up. I'll give you the scope view of things here. It's the upper, let's just put it in the middle. I'm on the 5 volts per division. Okay, so just kind of randomly at one of the 3 terminals. This one first. This I think is the bypass capacitor. So there's a little bit of hum there. It's very, very hard to see, isn't it? Okay, that was one. Now another. Oh, there's just AC sitting there. That's probably the input side. And the last one, this is probably the output side. You see there's lots of hum there still. So that would be about a volt. And there's probably, what was it, 250 volts there. A volt and 250. So the hum is around 0.5% or something like that. So I think I need to augment those or replace them to get rid of the hum that is in this radio. It's not very distinct in the speakers because my speakers are so tiny in here, but I'm sure if I put that on the big speaker we will be overwhelmed with hum. Okay, great. So far, okay. I haven't done anything bad to the radio. That's the main thing here. 2 more capacitors to go. This is 22 and 24. Let's take a look on the schematic here and whatnot. 22 and 24. 22. There's 20. There's 24. That's the bypass on this cathode resistor. And 22, there's 22, which is grounding this. So they're doing very different things. So I'm going to do these one at a time and see what happens. I think this might be the next one to do. So this is trying to provide a ground, a signal ground right here. 0.05, and that's C22. So that's what I'm going to do next. Okay, C22, that's the grounder of the IF transformer. We're all ready to go here for another test. Yeah. Oops. Okay, let's try that again. There we go. So the interesting measurement here really is just what happens on the meter. Sorry, when I changed those first 2 capacitors, I had reasoned they would have no effect on the IF. This is the one that could have some effect on the IF tuning. So if we look on the scope here, so that's the input level, about the same. What's the other scope doing? The other, well, that's on the speaker. We don't hear a thing. Okay, let me give it full voltage here too. We don't hear a thing. That usually means I made a mistake. I may have, no, I was going to say I may have installed a short circuit. No. Well, this is quite a dramatic difference here. Okay, back to the. What has changed? So I did disconnect some stuff from here, but it's all reconnected. Did not change any of that, any of this or that. The ABC voltage is way down. Well, let's try tuning the signal generator here. I'm going to let you look at that meter while I do it. Okay, meter, watching the meter. Down and down. So the resonant point is still in the same place. It's not quite the not what I was looking for. Let's turn up the frequency so we can hear something. Good idea. Okay, I hear it. Not very loud. Let's turn up the volume. This kind of ruins some of the test. Well, I don't know what to think about that. create a short circuit there. Well, it is what it is. One more capacitor to go. This is the one that's bypassing the cathode resistor on the IF tube. I should check the cathode resistor also. That was something like a 270. So I see a resistor there. That's probably it. So let's check it. Just assuming all the voltages are gone. So I'm right in the area where the power cord comes into the radio. There's 120 volts potentially sitting there if I don't remember to turn it off. That's why I like to unplug it, because there's zero chance. Okay, we'll go there. So this is across the what I'm sure is the cathode, or I believe is the cathode resistor in circuit. So it thinks it's a capacitor, 32 picofarads. No, it's not a capacitor. Okay, let's try the regular ohm meter. If there is such a thing as a regular meter. I think it was 270. I think. There we go. Oh. Okay. What do you say? Hmm. 416. 416. That's not so good. If it's supposed to be 270, let me just take a peek here quickly. Let's say 270. And the colors on that guy, body and dot, red, violet, and then the dot is well, it could be green. Well, that would not be right. Maybe that's brown. Hard to say. Okay, I'm going to nip it out of there because we have enough indications that it's not good. We'll see when I get it out. Now I'm going to put some clip leads here. Either position where that just came from to help me not forget where it came from. So here it is. Body and dot. Red body, purple, and looks like a green dot. The 417. Definitely not supposed to have a 4. The body is definitely red. Okay, so I'm going to get a 270, stick it in there, and carry on some more. Well, while I was replacing these two capacitors, I discovered I'd made an error with the big 10 microfarad capacitor and hooked it up to the wrong spot. So I've corrected that, but that kind of makes all this testing kind of questionable now. This guy, as I was taking him out, this happened. So I think this capacitor is shot. That's done. last one even looks like it's popping out a wee bit too. But that's how these things get separated and just become nothings. They lose their connections. But we'll test this one. $50 volts. How bad do you leak? So the eye didn't open at all. It's a dog for sure. No surprise in any of that. Okay, so we're ready to operate this again. Get this clip lead out. Okay, he's a dead guy. He's dead. 2, everything is connected just as it was. How about we plug it in this time? Okay, so we're liable to see quite a dramatic change here, but we won't know exactly why. Okay, everything left alone. Dim bulbs. It's amazing how you can hook something up in totally the wrong spot and fire does not ensue. Especially a big part like a big capacitor. You'd think it would mean big trouble. Okay, I hear it. Oh my gosh, the AVC's even lower. But I've been fiddling around here a bit, so let's try tuning, first of all. Tuning the signal generator. No, it likes the same spot. And we were getting a big voltage there before. 25 volts. Now we're getting just a little voltage. Could it be this is correct? The other was wrong. And what about what the signals look like? Let's take a look. What we got? So that's the input signal, still roughly the same. And the other scope lead is looking at what's coming out of the speakers. Okay, so we're putting in about 1,000 hertz right now. That's not really, it's not very straight, is it? It's got some weird stuff going on. That's 80 right there. Kind of the same as it was. About the same level. I fooled with the volume control here, so you know the level doesn't mean too much. Okay, not sure what my test proved. I don't know if they really proved anything, but I'm sure the radio's getting better and better. Maybe we should listen to it at this point. Sounds like a good idea. I'll get set up just so we can just test it. Hear what it sounds like. Okay, this is hardly the best arrangement, but I've got the antenna plugged back in. All of its shorting wires. They're definitely shorting here. So just how well this is going to work. Probably not. I can't really adjust that. Okay. Volume down. Okay, and power on. There we go. Okay, full voltage here. The last few tests I did, I had the radio on reduced voltage, but off camera I flipped it onto full voltage. It really didn't do anything different. Okay, let's just make sure this is nowhere near the IF frequency. Well, what can we get?
They had to move on, and when he came out with the video that really was not anchored down a couple of laps, they just couldn't have that. Here's our franchise quarterback for 30 weeks ago.
Randy Mueller, former NFL general manager and co-host of the Football GM podcast. Randy, let's play make believe for a second here, because the deal's already done. He's a Ram, or you can pretend to be in Rams management.
Well, there's lots of volume now, but it doesn't sound very good.
OBJ, is it simply looking at it? This is obviously very plain layman's perspective. He's a talented player who has not.
Okay, not to be upset about that though, because there's still more to do. There's an alignment effort that's got to be done, and I have to consider these small capacitors. And did I miss some paper ones up in there? Maybe way up in there. There is a couple. So still more stuff to look at. There's other capacitors previously replaced. I found the ones that were done were the wrong size, so there's a good chance these are the wrong size too up here. So lots more to do yet. I have not tested the tubes. You could have a weak detector tube. All kinds of possibilities still, degrading the operation of the radio. So today's experiments didn't go all that great, but nevertheless I'm sure the radio's operating a bit better than it was. Great. Thanks a lot for watching.